presentation by Dr. Ellen Wohl, The Importance of Resilient Watersheds, exploring how disturbances such as wildfires, floods, and droughts have intensified across the western U.S. in recent decades. Wildfires set off a chain reaction of hazardous debris flows, flooding, and degraded water quality that can impact water supplies, infrastructure, and ecosystem health for years. In many cases, these events are followed by river restoration projects designed to help watersheds recover and better withstand future disturbances. Dr. Wohl is a distinguished professor in the Department of Geosciences at Colorado State University and the author of 20 or more books. Hey, Chris. Yeah, Billy. What did the beaver say when he woke up in hell?
Billy, what did the beaver say when he woke up in hell?
Well, I'll be damned. I know that it may pain most of you for me to give up the microphone, but without further ado, it is my great pleasure to introduce Dr. Ellen Wohl.
Thank you for the introduction. Whoever was talking, you've relieved me from any anxiety that any joke I might make would be worse than anything I've been hearing. So with that, let's talk about the importance of resilient watersheds. I'm going to start with some definitions of exactly what I mean by resilience and sort of provide a conceptual framework of how I think about the processes and the features in a river that create resilience, and then end with some of the things that we as humans can do to foster resilience. And most of my work is informed in this talk by mountain streams in the Intermountain West. If I give this talk in other parts of the world, I have to say, but it still applies to your systems, but it definitely applies to the Black Hills. So to start with, I'm using the term resilience to indicate the ability to recover to pre-disturbance conditions, whatever those may have been. I start with this because resilient is used in a lot of different contexts. We talk about resilient people, resilient infrastructure, resilient ideas. In the context of a river, it's a system that can come back to, say, pool volumes or fish population densities or whatever metric you choose that were present prior to the disturbance. And I think of resilience as a continuum. Rivers are not resilient or unresilient. They're lots of different points along those two end members, or they can be, and different parts of a river, like fish populations versus pool volume, can have different levels of resilience following a disturbance. So, for example, you could look at a system like this. This is North St. Vrain Creek in Rocky Mountain National Park. It's flowing from right to left. This is a beaver meadow. So an area where there's many channels. You can see a lot of ponded water in the valley floor. You could look at that whole river corridor and assess whether it's resilient. Or you could look at a more specific feature of the channel, such as the number or spacing of channel spanning logjams, as you see in this lower photo, or the backwater pools associated with those. I'm using the term disturbance to indicate something like a wildfire followed by a flood and debris flow, or a drought, or a chemical spill. It's something that's often a very short-lived event it can be throughout a whole watershed, or it can be a part of a river. You can certainly have continuing disturbances like climate change or deforestation, but I'm going to focus on more short-term events in this talk. And many of these disturbances can initiate what scientists often refer to as a disturbance cascade. So you have a fire, but that's not the end of the story. And you all live in the Intermountain West, so you're, I'm guessing, very familiar with the effects of wildfires. There's the fire itself, but then in the 1, 2, or 3 years after the fire, you have to worry about precipitation. If you have intense rainfall, that can trigger flash floods and debris flows. So you get more water and sediment coming into the river valley from those burned hill slopes, and that creates a whole series of secondary effects that are referred to as this cascade. So just, I'll give you a disclaimer right away here. I am not an artist. So this is a side view of a hill slope on the left and a valley floor with, say, a large channel, secondary channel. Those green triangles are supposed to be conifers, and the single sort of orangish lines are downed dead wood. So you have an increase in water and sediment coming off the hill slopes, but then this triggers changes in the sediment moving down the river, whether it's in suspension or moving along the bed of the channel. You might see changes in the width-depth ratio, or you might go from a single channel to a braided channel, for example. So that's called planform geometry. You could see changes in the distribution of downed deadwood, like logjams, either in the channel or in the floodplain. You might see changes in the living vegetation, some of the other organisms, such as beaver, in the river corridor. So there's all these secondary effects that fundamentally affect the three-dimensional ability of materials and organisms to move in the river corridor. So three dimensions because you can have water and sediment and nutrients moving between the channel and the floodplain. In the vertical dimension between the surface and either the subsurface or the atmosphere, and of course the longitudinal dimension moving up or downstream, downstream for material and up and downstream for organisms. So again, these changes go on for a while. This cascade, the increase in water and sediment following a wildfire, for example, that's mostly in the first 2 to 3 years, but some of these secondary changes can persist for more than a decade. We've had a lot of wildfires in Colorado recently, and some of my colleagues at the U.S. Forest Service have been looking at water quality, particularly nitrate and phosphate, and they're not seeing those parameters return to pre-fire conditions, even though it's been 15 years since some of the fires are looking at. So this, whether you're going to call a system resilient or not, partly depends on what variables you're looking at, and partly what time frame you're willing to consider. Some variables return quite quickly to pre-fire conditions, others take a long time. And when I say river, I'm really using that as a shorthand for river corridor. If you say river, most people think of the channel, and that's all. What I've called the active channel here, the part where the water flows. I think for those of you who are fishermen and fish in areas where there's secondary channels, you're very aware that it's not that simple. So the phrase river corridor reflects the fact that there's an active channel, there's an adjacent floodplain, and there's an underlying hyporheic zone. And if you're not familiar with that phrase, it sounds a bit intimidating, but hyporheic comes from the Greek roots for below and flow. So it's water that starts in the channel, goes into the subsurface for some distance, and then comes back into the channel. And it's sometimes called the river's liver. It's a very important component of the river corridor because there are microbial communities that live in that shallow subsurface zone that are very good at removing nitrate, for example. And they also, the invisibles die down there and their cells come back into the channel with the return flow from the hyporheic zone, and that provides food for microbial communities in the channel. That upwelling water from both groundwater and the hyporheic zone tends to be cooler, so it's particularly important for salmonids. So the point in using this phrase river corridor is to be more explicit that a channel doesn't exist in isolation. It really is connected to the adjacent floodplain and the underlying hyporheic zone. And I've got this block diagram here, mostly showing things moving downstream. There's something coming in from the adjacent uplands, but there's a lot more going on. There's hyporheic exchange between the channel and the floodplain through the banks. There's movement downstream. There's hyporheic exchange with the bed. There's groundwater discharge coming into the channel or going out of the channel. There's material at the surface going back and forth between the channel and floodplain. So there's all these interacting components and degrees of connection. And when you start looking at resilience or the effect of a disturbance cascade, again, it's not just the channel, it's also what's happening in the floodplain and what might be happening on the bed that affects hyporheic exchange, for example. And a lot of what I'm going to be talking about is focused at the reach scale. So I think of a reach as a length of river that has consistent characteristics. It could be between successive tributary junctions, or again, if you're familiar with mountain rivers in the western US, you know that many of them change pretty abruptly downstream. You could be in a very steep, narrow canyon and go into a floodplain reach and then go back into a canyon. So those reaches could be tens of meters or let's say tenths of a mile in length, or they could be thousands of meters or miles in length for larger rivers. The point is, it's a length of river with consistent characteristics, whatever scale that might be at. So when I think about what goes on at this reach scale and what might influence resilience, I start with the shape of the river corridor. Is it what I've called a string here, which is, these are not my terms. String and bead comes from work by stream ecologists back in the 90s. They said, if you look at gravel bed rivers in the Northern Rockies on a map or in Google Earth or aerial imagery, you can see the line of the channel that looks a little bit like a string. It's narrow and simple. And then interspersed along that are these wide reaches where, as you see here, you might have secondary channels, maybe braided rivers, much wider floodplain. It looks like beads on that string. So beads and strings, this downstream alternation between very narrow, relatively steep portions and wider portions, is very characteristic of mountain rivers in particular. So again, when I start thinking about influences on resilience, I start with this configuration. Am I in a bead or a string? And that really reflects the lateral confinement. Do you have a gorge or do you have a floodplain? And lateral confinement tends to go with downstream gradient. If it's narrowly confined on the sides, it's often steeper. Spatial heterogeneity here is another mouthful. It just means, is it just a single straight channel, or is it something more like this bead where there's secondary channels that branch and rejoin, there's floodplain wetlands, there's bars, there's islands, there's more patches in the river. You could think of it that way, where a patch is a discrete unit that's different than what's around it. So hopefully you can see my cursor on the screen. You know, this island or bar here could be a patch, or this floodplain wetland would be a patch. And there's just more room for spatial heterogeneity or patchiness in these bead sections. So start with that. What's the physical configuration? And then what's coming into that river corridor? And I tend to think of this sort of tripod or trifecta of inputs. In all rivers, there's water, and in all rivers, there's sediment. And then in forested rivers, there, at least historically, was wood, which I've, LW here means large wood. So individual pieces or logjams. I say historically because when you were talking before this seminar about stream cleaning, I sort of cringed because I've heard that used to describe removing wood and log jams. It's like, oh, no, no, don't tell me they were doing that. But I completely agree with removing shopping bags and shopping carts. That's good stream cleaning. But of course, the industrialized world has a long history of removing wood from rivers, treating it as debris. There are interesting records that the predecessors of the Army Corps of Engineers kept for several decades in the US, and they removed literally millions of logs from rivers like the Mississippi, the Ohio, the Illinois, some of the big rivers used for navigation. So most of us are not used to thinking of large wood or log jams, even in forested rivers, as a natural feature, but it is natural and it's very important. So again, I start with the configuration of stability, and I think about what's coming into it. And then I think about what the living components are doing. So riparian vegetation, whether it's woody plants or herbaceous plants, in lower gradient streams, aquatic vegetation can be very important. And everybody's favorite subject for bad puns, beaver in North America in small to medium-sized streams are very important. And there's feedbacks or interactions between each of these, between that physical configuration, the physical fluxes, and the living organisms. And those feedbacks partly depend on there being space to adjust. So again, if I go back to this bead and string, if you double the discharge coming into this single channel that's narrowly confined, mostly what happens is the water just flows faster. It's got more energy, so it may erode the channel banks if they're erodible as opposed to bedrock, but it mostly just goes faster. But if you get down here into this bead and you have more energy because you've doubled the discharge, you may see meanders become more sinuous, or you may see secondary channels forming, or wood being moved from the channel onto the floodplain. There's just more space for making a variety of adjustments. And in this wider lower gradient bead, many of those adjustments will act to slow down the movement of water and sediment. So that's what I've referred to as attenuation of fluxes. Remember the disturbance cascade, it starts with more water and sediment coming into the river corridor. If you have something like the string sections, if the entire river looks like an irrigation canal, all that extra water and sediment goes downstream very efficiently. Irrigation canals are designed to be efficient. So in the Western US, that means it goes into a lake or an irrigation reservoir or water supply reservoir, and it creates a lot of problems. If you have a river network that has multiple beads along its length, whether there's logjams or beaver dams or just things like floodplain wetlands and secondary channels in those beads, some of that water and sediment is going to be spread across the entire floodplain, and it's going to move more slowly, and the sediment in particular is going to stay there for a while. So you're attenuating the magnitude or the amount of material going downstream quickly after a disturbance like a wildfire. Okay, so the idea here is that that spatial heterogeneity or that patchiness really promotes the ability to absorb that disturbance cascade by slowing down the movement of water and sediment and fostering at least temporary storage of water and sediment. And spatial heterogeneity here, what exactly does that mean? What are some examples? So you can have spatial heterogeneity of the stream bed, pools and riffles, or cobble sections and sandy sections. Again, as opposed to, I always use an irrigation canal because I think most people in the West are familiar with that. It's straight, it's homogeneous, the bed is at the same gradient, the cross-sectional geometry is the same, it's uniform. So you can have heterogeneity of the stream bed, you can have heterogeneity of the banks. This photo here on the lower left is a small subalpine stream in Wyoming. Those are just little embayments and protrusions along the stream banks, but there's a little bit of flow separation or slower flow in an eddy in each of these embayments. There's a little bit finer sediment there. There's a little bit of slowing things down. And if you've got big heterogeneity in the banks, like meander bends, for example, slows down part of the flow even better. Heterogeneity of the cross-section, that just means instead of having a uniform symmetrical cross-section, you've got deeps and shallows, like pools on the outside of meander bends and bars on the inside. Channel planform is what you see when you look down in map or aerial view. So the photo on the right here from the Canning River in Alaska, this was on a raft trip a couple of years ago. You can see the boats and some people standing there for scale. The river is flowing from the top of the photo towards the bottom, and the main channel is over on the left. On the right, what you see are those little secondary channels that have been formed across a bead, really, a wide section of the floodplain, and they're creating spatial heterogeneity. So instead of just having a single channel, you've got all these little channels, and it's very hard to see in the sun angle in this photo, but if you can see the cursor, the main channel is fed by melting glaciers, so it's very turbid. These secondary channels were crystal clear. They tended to be warmer, and when we did this trip, which was around the solstice a couple of years ago, we saw a lot of fish in those clear secondary channels. We saw a lot of juvenile fish in particular. It's really good nursery habitat for grayling and for some of the Arctic char in this system. Floodplain morphology, that means what you're seeing in the Canning River photo. Secondary channels, floodplain wetlands like lakes, ponds, marshes, swamps. Any of these features that I'm talking about are sources of patchiness that can help to spread out water and sediment following a disturbance, and again, slow down that movement and store some of that material. And storage may be only a matter of minutes, or it could be years to decades for sediment. But if everything doesn't go downstream at the speed of sound, or faster, as you may have, or not faster, a little bit slower, as you may have in a large flood, then you're helping to attenuate that flux and creating a little bit more resilience for downstream areas. So how do you get spatial heterogeneity? Well, it's back to the slide I had a couple minutes ago, but it starts with those geologic controls. Where do you have beads and strings? And one thing I didn't talk about with beads and strings is why they're even present. There's multiple reasons. You could have a change in rock type. It could be glacial history. For mountains, it could be the same rock type, but differences in the ability of that rock to resist erosion because of differences in what are called joints. They're like hairline fractures in the rock. So the general term is just geologic controls. That creates that downstream alternation between the beads and the strings. That interacts again with the vegetation and the animals and with those fluxes. And all of those interactions drive what the channel is doing from side to side. Is it a channel that's fixed in place like a string, or can it meander? Can it move across the floodplain very abruptly, something that's known as avulsion? Can it form secondary channels? Those interactions also control how much of the flow goes overbank across the floodplain and submerges the floodplain, and how much sediment is deposited there. And that movement of the channel from side to side across the valley floor and that overbank flow and potentially sediment deposition creates some of these variations in space and time and things like the bed forms, the grain size distribution, again, sand, pebbles, boulders in the channel bed, the shape of the channel cross section, whether the channel is sinuous, single thread, braided, and the characteristics of the floodplain. So there's this disturbance cascade within a reach, and then you can also think of a network, and this is just some generic stream network that I drew. But the point I want to make here is that many of us, including the entire country of the United States in a legal context, particularly our Supreme Court, ignore the really small channels that may go dry for part of the year or that are absolutely not navigable. You can walk across them without breaking stride. But those small channels, what are called first order streams that have no tributaries, or where two first order streams join, it's called the second order stream. Together, those constitute the headwaters of a network. And globally, or in any particular river network you want to choose, the first and second order streams together equal about 80% of the total channel length in that network. And if I do, sorry, this is what I wanted to do. Those little yellow ovals have just come on all the first order channels. So, you may, most of us are used to thinking about the main stem as the one that matters, but these are all the things that feed it, and they are the greatest portion of the length in any river network. So if you care about what's going on in those, even if they're not fish bearing, that has a big influence on what's going on in the fish bearing or fish supporting parts of the river network. Resilience at that network scale is really fostered by slowing down how things move through these headwaters. Again, with beads, with beaver dams, with log jams. The cumulative importance of these headwaters, any particular one of these yellow blobs may not be that influential, but together they are very influential if you're looking at what's going on in the lower part of the river. So again, there's this downstream alternation between strings and beads that often translates to downstream alternations between a single thread channel, just a single, not very meandering channel, and either an anastomosing channel, which is what I'm showing here, or a braided channel. I'm guessing everybody knows what a braided channel is, but it's a channel that has multiple secondary channels that branch and rejoin as you go downstream. They're often quite mobile through time. They move from side to side of the river channel. You have bars that form and then disappear. Anastomosing is similar to a braided channel, except that the areas between the secondary channels are much wider and more stable. So think of forested floodplain with small channels formed across it, as opposed to minimally vegetated sandbars where the channels are moving back and forth rapidly. This is an example of a river bead in a channel near where I live prior to a fire that occurred in 2020. And this is an example of one of the strings in that same channel after that fire in 2020. It's a single channel in both of these, but here it's got a big bend. There's more of a floodplain here. That's actually not much of a floodplain. It's a little hard to see in this photo, but the floodplain is only about 10 feet wide on either side. So those valley segments that have more space, more floodplain, and more patchiness are really the most important. They're disproportionately important in attenuating some of these increased inputs of water and sediment after a disturbance. Another way to put this is not all segments of a river are created equal. Strings are like irrigation canals, or they're closer. They move things downstream very effectively, and they're very important in other contexts. But after a disturbance, when you want to slow down the downstream movement of all this extra water and sediment, it's those beads that become really important. They're the most effective parts of the network for slowing things down. If you're in a bead, you can store water in backwaters, behind dams, in secondary channels, in overbank flow on the floodplain, in the subsurface reservoir, whether it's the hyporheic zone or the floodplain aquifer or groundwater. You can store sediment, and OM here, that stands for organic matter, bits of leaves, twigs, pine cones. In forested rivers where there's a lot of shade, there's not a lot of algae to create the base of the food web through photosynthesis. So you may have this plant litter coming in that many of the aquatic insects eat, that then, of course, the salmonids eat. So that organic matter is also important to, it's important to slow down the downstream movement of that and sediment. And that can be stored, again, in logjam backwaters and secondary channels on the floodplain, if it can get there. You can have a wide section of river, but if you've got artificial levees or the channel has cut down and it doesn't really access the floodplain anymore, then things still move downstream very quickly. So in addition to some of the river ecosystem effects from a human perspective, we usually want to attenuate those water and sediment fluxes because we want to reduce the hazards associated with flash floods and debris flows. I'm sorry, I don't know off the top of my head what the recent history of fires has been in the Black Hills, but Colorado has had an awful lot of wildfires in the last 15 years, and far more people die in floods and debris flows after the fires than are killed in the fire itself. So you want to slow down the movement of material. You also want to slow it down because if you get a big flux of sediment into a water supply reservoir, you have a lot of phosphate attached to that sediment. Phosphate is just a form of phosphorus, and phosphorus is a critical nutrient for all living organisms, including us. But if you get too much phosphorus, then you have blue-green algal blooms. It reduces the dissolved oxygen in the water, which can kill fish. If it's a water supply for drinking water, then you have to add extra chemicals to purify the water. Same thing with what I call denitrification here. Nitrate is just a form of nitrogen. Again, nitrogen is a critical nutrient, but too much of it is a very bad thing. And you often get an increase in nitrate coming into river networks after wildfire. So if you can shunt some of that water into the subsurface, store it behind logjams, get it out in the floodplain, there are microbial communities in those environments that remove some of that excess nitrate. If the nitrate goes downstream really fast to drinking water reservoirs, again, you have problems with blue-green algal blooms and water contamination. So what I'm showing in these photos at the bottom are just examples of some of these spatial heterogeneity. The Hague Creek, that's a beaver dam with a nice pond behind it. The Yukon River, that's a floodplain wetland. Mill Creek, that's a tiny little creek that you could sort of gather yourself and jump over pretty easily. A very small logjam, but it's slowing down the movement of material for days to weeks. Probably not for years, but a little bit at lots of places along the river in terms of slowing things down is very important. So I'm going to just quickly go through an example from Little Beaver Creek, which is about an hour's drive from my house. It's about a 40 square kilometer drainage. I'm sorry, I don't think in English units. Let's say like 100 square mile catchment. Prior to a wildfire in 2020, it had old growth montane forests, so ponderosa pines. There were a lot of log jams along the channel, like the one you see here that went all the way across the channel, lots of old beaver dams. It's dominated by snowmelt, but we do get summer thunderstorms in July and August and early September that can create flash floods. Very intense wildfire in 2020. This was a human-caused wildfire very late in the season, so it was high severity, and the creek was at base flow, so even log jams in the active channel were charred, and the riparian corridor in places was completely denuded. You can see here, it looks like I'm in a desert with charred tree trunks. We had a series of flash floods and debris flows in the runoff seasons of 2021 and particularly in 2022. And the one in 2022 was huge. We had a very intense convective storm over the burned area. It created what is by far the flood of record. There's no gauge in this stream, but if I had to guess the recurrence interval, I would say at least 300 years. And the log jams that had been on the channel moved out to the floodplain. So this is on the floodplain. There's a bunch of sand deposition upstream of this log jam. That's one of my grad students standing out of her scale. It's amazing if you spend time in the natural world to see the effects of a flood or a debris flow. It's even more amazing if you are really familiar with the place where it occurred. And I've been working in this watershed since 2014. So it was kind of shocking to see what this flood did. What we saw was that the strings, so the valley segments, or excuse me, the beads, the valley segments with less lateral confinement, more floodplain, more patches or spatial heterogeneity, they really slowed things down. There was this tremendous flood, huge recurrence interval, huge amounts of water, sediment. But where this Little Beaver Creek joined the next larger channel, which is the South Fork Poudre, there wasn't very much effect. There was a small fan that formed, but nothing dramatic, because there were so many beads along this channel that slowed things down and stored water and sediment that the output at the watershed mouth was not that big. So the beads were really effective at attenuating these downstream fluxes of water and sediment after the fire. The beads are just over 10% of the total valley length, but they stored a quarter of that extra sediment that came in 2021 and 2022. And again, where was this occurring? Well, there was sediment and that particulate organic matter in logjam backwaters and secondary channels and across the floodplain. There was water being stored in the backwaters, secondary channel of the floodplain, and the hyporheic zone. I'm repeating what I had said earlier. And again, that reduced the phosphate inputs downstream, helped to create denitrification or remove some of the nitrate moving downstream. Okay, so this is how natural systems work. What does this mean for those of us who are interested in working in rivers, storing rivers, managing them? Well, management and restoration that focus on those beads can really enhance the disturbance to that cascade that occurs after a wildfire or a flood, particularly for the larger rivers that these small rivers feed into. And just a schematic of this for Little Beaver Creek, what we saw was during that big flood, the entire valley floor was inundated. That's my field notebook with some of that coarse particulate organic matter that was like a high water mark that was tens of meters or tens of feet from the active channel. The narrow reaches, that excess energy of much more water created a lot of erosion. The channel cut down and the banks widened. In those wide, low gradient reaches, there were a lot of beaver berms, which were breached old dams, and there was pretty dense floodplain vegetation. So we definitely saw material moving from the channel onto the floodplain, but we didn't see nearly as much erosion in the channel. A lot of that material is now stored in the floodplain, material being sediment and large wood. The log jams on the floodplain help to create secondary channels. So channel avulsion just means that part of the flow moves across the entire valley floor and creates a new channel. And what you're seeing in the inset on the left there is a new channel in the process of being formed across the forest floor. Nick Point is just a little waterfall. So this is a tiny waterfall, about knee-high, on the floodplain where this newly forming secondary channel comes back into the main channel. And it created that system of channels that branch and rejoin, or anastomosing. Those floodplain log jams, I don't expect to go anywhere for decades. I could be wrong, time will tell, but I don't expect to see a flood of the magnitude that we saw in 2022 because now the upland vegetation, at least the ground cover, is regrowing. So that will slow down the movement of water and sediment during intense rainfall, slow the movement of water and sediment from the hill slopes into the channel. So the floodplain jams are going to stay there, but they're really important during overbank flows for a variety of aquatic organisms. And when the floodplain's dry, there have been studies that show that they help to increase soil moisture, soil nutrient content, they foster greater plant diversity, and all the what I'll call little guys really like um, individual pieces of large wood or log jams. And little guys is everything from bacteria and fungi to um, insects, things like termites, ants, various types of beetles, reptiles, amphibians, small mammals, birds, sometimes even medium-sized mammals like pine martens or wolverines will preferentially use log jams. So there's this persistent increase in connectivity between the channel and the floodplain that is, next time we do have a large flow, if it's easier for the water to move out into these multiple flow paths, like going into smaller secondary channels where the flow is slower, that's going to limit the erosion associated with those subsequent floods. Because if you break water up into multiple channels, make it move more slowly, it's got less energy to erode the channel boundaries. So it's going to increase the erosional resistance. And again, it's going to slow down those downstream fluxes of water and sediment. So spatial heterogeneity here is really increasing the resilience to these disturbances. So this basic idea that you can have patchiness or spatial heterogeneity promoting resilience by attenuating these fluxes, That can apply to the Mississippi or the Amazon, or to your local headwater stream. It applies across a variety of spatial scales. The basic ideas don't depend on scale. And if you have more patches or more heterogeneity, that often reduces that longitudinal connectivity, so the ability of material to move downstream, but it enhances the lateral and vertical connectivity. So these arrows that I've put in here, this channel spanning logjam, it's an obstruction. So when there's high flow, it's going to force some of that water out into the floodplain. And again, that's going to slow it down, allow some of the sediment to be deposited. It's also going to create an obstacle that forces some of the water into the subsurface for that hypereic exchange. The water will return to the surface downstream, but beaver dams and logjams are very good at promoting that vertical connectivity. And examples of this, since we had bad beaver puns at the beginning, I'll use beavers as an example here. Beavers modify river corridors. They build dams that create ponds. They also dig canals across the floodplain that create secondary channels. Just putting an obstruction across a channel in the form of a dam forces some of the flow over bank onto the floodplain. That can allow the formation of secondary channels. So you end up with what you see in this lower photo, which is many channels branching and rejoining, multiple ponds if there's space on the floodplain. Ponds of differing ages, dams of differing ages. If you've ever spent time in what's called a beaver meadow, which is misleading because it's not really a meadow, but it's an established term. Let's say a beaver wetland. You're aware that they will dam tributary channels, they'll dam seeps and springs, they'll build dams that are parallel to the main channel, perpendicular to it at different angles. It's a very complex environment. The upper photo is at ground level in one of these. It's hard to tell here, but there's 3 different channels coming together. So again, that's slowing down the movement of everything moving downstream here. And this was taken in early in the growing season. The willows are just starting to leaf out, but I can attest from personal experience, it's extraordinarily difficult to walk through those dense willow thickets. And that means it's hard for water and sediment to move through them too. So you're tending to store material in here. And of course, because it's very wet, it's a good fire break or a refugia for organisms during fire. And I think Emily Fairfax talked about that in a previous seminar in this series. The photo in the middle right here is from my colleague at Utah State, Joe Wheaton. This is a site in Idaho right after a fire. The uplands are burned. The river corridor that was modified by beavers is not. This was an abandoned pond, the photo on the left in the middle, in Little Beaver Creek. It had been abandoned before the fire, but the dam was still partially intact. It had willows and other vegetation growing on it. When we had that 2022 convective storm and debris flow, all the old beaver dams just filled up with sediment. So there's a lot of sediment being stored there that didn't go downstream immediately into a drinking water reservoir or into silting up fish habitat downstream. So beavers, I think I know you've heard from Ben Goldfarb and Emily Fairfax, so you've heard this message a lot, but beavers really are our friends and fish friends in a lot of senses. So summarizing this, there's this geologically induced spatial heterogeneity of alternating beads and strings that interacts with what I've called biophysically induced. That's just logjams, living vegetation, beaver, and determines to what extent you can attenuate water and sediment moving downstream after a disturbance, and whether the entire network is resilient or is not resilient, or recovers quickly or not from that disturbance. We can get involved in this. We, as humans, management and restoration can foster spatial heterogeneity, and I think they're most effective if they're focused on those bead reaches. So that's what I mean by selected reaches. They can really enhance resilience to the disturbance cascade. So what exactly for management and restoration? Well, I put protection first because this is a very, very high level science, but everybody knows Humpty Dumpty, the nursery rhyme, I think. You remember the line, all the king's horses and all the king's men could not put Humpty together again. I am a big fan of river restoration, but people do not do as good a job as natural processes. So the first step, the most important thing I think we can all do is protect existing natural systems that function well. And we all know they are subject to many stressors and threats at the most upper level, ongoing everywhere is climate warming, but protecting the existing ones is the first step. And then you can either have active or passive restoration of others. And active restoration, sometimes referred to now as valley reset or stage zero restoration, that's often designed to create something like an anastomosing or a braided channel, or a channel with multiple branches that rejoin downstream. You can have, there are lots of phrases out there. Natural flood management is one that's used in the United Kingdom. Low-tech process-based restoration is used more in the US. There's a slew of acronyms. ELJs are engineered logjams. So there are studies from around the world that show that if you completely deforest an area, remove all the wood from a river, even if you stop mucking around with it and let the forest regrow, it takes on the order of 200 years to go back to natural levels of, or pre-disturbance levels of wood in the channel and log jams. Most people don't want to wait 200 years, so you can jumpstart the process by reintroducing wood. So that's engineered log jams. BDAs are beaver dam analogs. PALs are post-assisted log structures. They're both human versions of beaver dams. If you want to help the beavers get established, or if it's not feasible for beavers to be in a reach for some reason, you can mimic their activities. You can construct wetlands. Valley reset or stage zero often involves reducing barriers to overbank flooding. And if a channel has cut down and is now a trench, maybe laying the banks back and creating some depressions in the floodplain that can become wetlands. Biotic manipulation, again, just beaver reintroduction, replanting willows or other native vegetation. So a couple of examples. This is a site in Pennsylvania. Prior to restoration, it was a down-cut channel with fairly dry banks. There was no lateral connectivity between the channel and floodplain. The flow never went over bank. The browner, the lighter colored sediment you see here is all old mill dam sediment that accumulated behind mill or in mill ponds when water mills were used for power. The people who were working here were able to determine from the geologic characteristics of the site and some of the fossils in this darker pre-dam sediment that before the construction of mill dams, this was one of those multi-channel systems with channels that branched and rejoined in a wetland. So they removed what's sometimes referred to as legacy sediment with heavy equipment, just took the whole valley floor down to the pre-dam level. They created some channels and that branched and rejoined, but then they left them alone to adjust on their own. And this is what it looked like within a couple years as vegetation started to grow. And this is a drone view of what it looks like today. It's a very successful project. There's been a lot of monitoring going on here by people at Franklin and Marshall College, the USGS, and some of the local agencies. And it's doing exactly what they hoped. The water quality has improved. They're seeing a lot of biodiversity. They're seeing fish come back. And it's a much more resilient system. When a flood occurs now, the floodwaters can spread out across this floodplain and slow down and deposit sediment, and you can remove some of the nitrate and phosphate. Another example from the western US, this is a Google Earth view, South Fork Mackenzie River. There's a dam in this photo. This channel flows from right to left. It joins the Mackenzie. There's a dam just out of the photo to the right. This is what it looked like in 2011. The Forest Service came in, and before I go to the next photo, you can see some old abandoned channels here, but mostly the floodplain is forested. Forest Service came in and did a valley reset. So they did lower some of those steep cut banks where the river had cut down. And mostly they reintroduced an enormous amount of large wood that allowed the river, there's so many obstructions now that this allowed the river to reoccupy some of its abandoned secondary channels and create a much broader active floodplain. This is what it looked like on the ground when I was there prior to their big fire in 2020. After the fire, this was one of the few places where the riparian corridor, the river corridor, didn't burn. It was a wetter area and it was very resilient to the fire. Little Beaver Creek, the place I've just been talking about, this is the downstream end. It was in pretty good shape to begin with, but the local watershed group got a lot of money from the Biden administration after the fires, so they recreated some of the patchiness that was here prior to the fire. They put in beaver dam analogs, and you can see these are very small structures, post-assisted log structures. And the next photo I'm going to show you is a ground view, sort of just below that caption or the name Little Beaver Creek. This is what it looked like. This last spring. Photo was taken on April 29th during the snow melt peak, and these portions of the floodplain hadn't been flooded in a while. I should say, I didn't explain this earlier. It's called Little Beaver Creek, and there are lots of abandoned beaver dams, but there were no active beaver dams. All the abandoned dams were at least partly breached. But now they've put in some of these beaver dam analogs, and the beaver are coming back. And I always imagine the beaver looking at a BDA and saying, we can do better. So they build big beaver dams on top of it that have an even greater effect. So this is a good example of pretty low tech, very inexpensive manipulations that are really having a nice effect. And this is, again, what the floodplain looked like during peak flow this past spring. There's also passive restoration. You can remove things that limit the movement of organisms in particular, like dams, culverts, grade control structures that may create barriers for fish, especially smaller bodied fish that can't jump that well. You can remove some of the lateral limits on connectivity. So this could be human-built levees, and oh, I just see there's a typo there, sorry. Road embankments, stabilized banks. You can put in grazing exclosures. This is a grazing exclosure not for cows, but for moose and elk in Rocky Mountain National Park. We have a big problem, just like Yellowstone used to, because there are no wolves or no big predators, and there are a lot of moose and elk, so they are grazing the willows down to nothing. They're creating grassy meadows. So the Park Service has been putting in these grazing exclosures. This is one that was put in shortly before I took this photo. The animals are supposed to be excluded from the area on the left. This is what it looked like within a couple of years within the grazing exclosure, and that's a beaver bank den. You can just stop doing things that simplify the channel, like dredging or channelizing it. And you can try and restore natural flows or more natural flows if there's a dam, or sediment supply usually if there's a dam, or reintroduce large wood. So there are a variety of things that you can do, but I think to conclude all this, fundamentally, we need to understand what the sources and types of heterogeneity are in any particular river reach or river network, have some understanding of the processes that create that heterogeneity and allow it to persist. And then this third one is the really tricky point. Think about how much of the network do we need to have higher heterogeneity? We're not going to be able to restore the entire length of all rivers in a river network, but are there hotspots, if you like, that will be disproportionately important? Are there individual beads that will have a lot of effect if we can restore them? And then develop management strategies to either protect or restore these processes, or to jumpstart heterogeneity by reintroducing wood or beaver or keeping grazing animals out. And I see this as a partnership between scientists, between managers, and between just people who care about their river and their watershed and want to become involved. So with that, I will end, and I think hopefully we've got time for questions. I'm very happy to answer questions if you have them. Thank you.
Dr. Wohl, thank you very much. That was awesome. I've got the microphone in my hand. If you have questions, I'm going to bring the mic to you. That way everybody can hear. Let's start it off. Who has any questions for Dr. Wohl?
I'm more curious about the Black Hills, but how do you check the status of a beaver population? I mean, what is the status of our beaver population? What is it in Colorado? How do you monitor that?
Um, yeah, where do I start with the status in Colorado? Depends what you're comparing it to. So I have been interested and a little bit depressed to read some of the first written descriptions. In our case, it was the earliest one was the Long expedition, for which Long's Peak is named in 1819. There were a lot of beaver here historically, and there are relatively few now. They're mostly in protected areas. There aren't as many as you would think in the national park because of the high population densities of elk and moose. So many of them are in national forests or on private lands. I have not seen a number because we don't know exactly how many beaver were here historically. We know they were much more prevalent, but not globally, sorry, within North America, the estimates, it's an enormous range, but the estimates are 60 to 400 million beaver prior to commercial fur trapping, 6 to 12 million beaver today. Colorado would be a similar proportion, something like a tenth or a hundredth of what was the numbers that were present historically. So we've got a long way to go in restoring them. The one thing I'll add is that the Colorado State Legislature just this past spring passed a state bill that recognizes the potential for using beaver for river restoration. And this had been very controversial because of, sorry, it's late and I'm tired. The prior appropriation doctrine, which I think everybody who lives in the US is very aware of. It had been controversial because of reserved water rights, but basically Utah, Wyoming, and Colorado have come up with rules that if a beaver pond that will result from beaver reintroduction or a beaver dam analog is below a certain size, then it does not have to be considered in reserved water rights. They've also said that if there is evidence of historical beaver presence in a river corridor, then you can reintroduce them again, irrespective of reserved water rights. So that is a big change from the way things were recently. So I think we will be seeing more active beaver reintroduction across the state, but it's going to be limited. Habitat is not what it was historically. I would guess it's similar in the Black Hills. There's a lot of urban development in the Colorado Rockies, mainly for ski resorts or year-round tourist destinations. Many of those sites are just not suitable for beaver anymore. So we're never going to go back to anything approaching historic levels, but we've got a lot of room to increase the population in suitable habitat.
All right, thank you. Chris had a question.
Yes, Dr. Wohl, I'm curious if you have any book recommendations. If a person wanted to start reading about this, what would be your top three that a person should go for?
Well, my top one is one that a lot of people have never heard of, but it is my all-time favorite beaver book. It's called Lily Pond. It's by Hope Ryden, R-Y-D-E-N. It was published in 1984, and it is delightful to read, and it's also very informative. She was, I don't know if she's still alive. I haven't been able to find much, if any, I haven't found anything about her online. She wrote a series of books in the 1980s. She was a biologist, and she spent 4 years observing a beaver colony in upstate New York. And I am not a biologist. I work on the physical effects of beavers, but I learned a lot about beaver behavior from her book, as well as the physical and chemical effects of beaver. So I would put that one at the top. You've heard from Ben Goldfarb, so Eager's a good one. There are so many beaver books now. There are two that have come out just in the last couple of years, but I'll plug my own. I wrote one in 2019 called Saving the Damned, that used the North St. Vrain Creek in Colorado as a sort of microcosm to look at the effects of beavers in all environments. I guess the longer answer, that's already a long answer, but the longer answer to your question is depends on what you want to focus on. Some of them, like Ben's book, are more about people and beavers. Lily Pond is about just the beavers. I mean, it's really, she talks a little bit about people, but it's mostly about beaver. My book is a lot about rivers and beavers, so it goes into some of the things I talked about tonight, but in much more detail. And then there are some really interesting books like, what's it called? Once They Were Hats. That's a detailed history of the fur trade that's really interesting. So there are a lot to choose from. Oh, one other I'll mention, it's specific to Colorado, but Enos Mills in 1913 wrote a book called In Beaverland. He anthropomorphizes the beavers quite a lot, but he also was a very entertaining writer. So I found that one fun to read.
All right, thank you. Other questions? I might start telling jokes if I don't see some hands up.
Please, someone ask a question.
Another question.
Okay.
All right, Dr. Well, this one's going to be pretty vague, I think. How would a person or an agency or group of people go about starting to prioritize streams for restoration. So in the Black Hills, pretty much everything needs it. Everything needs to be fixed. So that being said, is there a couple of three things that we could look at to say, if you have this, you probably ought to be thinking about it, or if you have that, think about that?
I guess I'd start with opportunity. Do you have access, either a willing landowner or a federal agency that is willing to entertain ideas of restoration? That would be the first one. Second one would be prioritizing those beads. So looking for floodplain reaches of the river where you've got a little bit more latitude to do things and to slow down the movement of material and to create diverse fish habitat. I guess a third one would be, I'm just going to put it in a very fish-centric perspective, fish access. Maybe you create this beautiful fish habitat in the headwaters, but the fish can't actually get there because there's culverts downstream or irrigation intake structures that are essentially impassable barriers. So one would be, can you do things? Can you get there? Access for humans. The second would be, is it a reach that is going to provide a lot of benefit if you restore it? And then the third would be, can the organisms, if I'm assuming because you're fly fishers that you're particularly interested in fish, can they take advantage of it? Those would be the three I'd start with.
Okay, thank you. We got another question. Give me just a minute to get across the room.
Actually, while you're moving, I'll just add one thing. This is an open question that I don't think there's an answer to, but some people will argue that we need to focus on the most nearly natural system because we can restore a lot of function. Others will say, well, but the ones that are almost dead, those are the ones that are often close to people. And if you can restore a little bit of function, people see that and they appreciate that. And maybe that will build support for that type of activity. And I don't have an opinion on that, but both of those are valid arguments.
Nancy Hilding, as I understand it, the fish that the fishermen like to fish for in the Black Hills are all exotic. And the native fish were too shrimpy to be a desirable thing to catch. So then you have stream restoration projects that I have been seeing going on since 1990 when I started looking, where they're going in there and they're restructuring the stream to make it nice for trout, which are an invasive exotic species. And so in the meantime, the native fish, if you're going to find them, are off in some isolated spot where there's a dam or a culvert or something there that has prevented the invasive exotics from getting up to the last known refugia of the teeny small native fish. So I would like to know if you have other experiences where the small native fish are getting driven out by the desire to restructure all the streams to support the exotic invasive that the fishermen like to catch. How do you go about creating refugia for native fish that are not compatible with the introduced fish?
Yeah, I'm glad you brought that up, Nancy. That is a really important issue. In my area, it's not that they're teeny, but it's the cutthroats are the endangered natives, and it's the brook rainbow and brown that are really introduced that outcompete them. That's one time when barriers to fish passage can be very good. So if there are isolated habitats where the exotics can't get to, then it becomes very important to maintain those barriers that prevent, usually it's upstream fish migration. And you also, I think, have to have a pretty aggressive public education campaign because a lot of people think it's good to introduce fish into naturally fishless lakes or into headwater areas where the fish can't get on their own, but could have a self-sustaining population. So a two-pronged effort of protecting the feature that limits the access of the exotics and making sure people understand why that's important to have those areas that don't have fishable trout stream populations, something, you know what I mean?
Okay, thank you. Next question.
What are the ways in which climate change could affect the resilience of our streams and rivers in the West? And what are some of the things that could be done to mitigate that?
Yeah, that's the question that is going to take. How long are you all there for? It starts. There's multiple prongs. One is fire. There have been a whole series of studies across the Western US and in individual regions showing that fires are becoming more frequent, more severe. The fire season is extending longer in the year. There's just more fire. So that means more of the post-fire disturbances like floods and debris flows. A second one is drought. You're going to have, we are seeing snowpack and snowmelt runoff being replaced by rainfall. That means flashier hydrographs, less sustained peak flows, and potentially a change in the timing of the peak flows. A third one is declining water tables. And if the water table goes down, that means you also have less groundwater recharge into rivers, and groundwater is very important for keeping stream temperatures cool in the summer and keeping smaller streams from freezing to the bottom in the winter. So it's important for helping fish to survive the periods of greatest stress, both in winter and summer. What else is going on with climate change? The water temperature is increasing. Stream temperature tracks very closely with average air temperature in the river corridor, and average air temperatures are increasing. We're also, of course, there's, I think, pretty good evidence that much of the forest die-off in the West is being exacerbated by drought and by either exotic or native insect infestations. And in my area, it's the mountain pine beetle, now the spruce budworm. They're both native insects, but they are becoming much more numerous and virulent because we don't get as severe winter temperatures that can limit those insect populations. So it's not just a double whammy, it's a multi-whammy. It's fires, less sustained and earlier peak flows, less groundwater recharge, forest die-off, and warming streams. Many of these things, there's not a lot we can do about. I mean, you can try and manage forests to reduce fires. You can, I don't mean to sound too pessimistic, but I've kind of given up on getting people to not do stupid things during fire-prone seasons that create human-caused wildfires. Somebody always seems to start fires. But you can try and make the forest a little bit less prone to extreme fires through thinning or prescribed burns. But for many of these things, they're kind of beyond our immediate control. So the most important thing you can do is to create these heterogeneous river beads. They're not just places that are resilient to disturbance. They're also refugia during some of these other stressors. So if you have a portion of river corridor that has secondary channels and main channels, it's got floodplain wetlands, it's going to retain water better at the surface and in the subsurface during droughts as well as fires. It's probably more likely, or it's more likely to be connected to the groundwater. So it's going to have some of that groundwater input that helps to reduce water temperatures. If it's a wet portion of the floodplain, the forest is going to be healthier, a little bit more resistant to beetles and fire. So you're more likely to keep those trees and keep those shading, or that shading that helps to reduce water temperature and air temperature. So the most important thing is to keep those beads in a healthy condition. That's the most immediate action that I think we can take.
Very good. Ray, you have a question.
Hi, I was kind of curious for let's say you have access to an entire watershed, all the streams and beads. Would you, like when you're starting a restoration plan, would you kind of target the absolute upstream or a little bit more downstream where you get more sediment? Like where's kind of like the ideal place to start in a watershed that's like nearly completely degraded?
I'd start in the upstream end because that will help you by the time you work to the downstream end. You'll already be reducing some of the stressors on the downstream end. So I think, can you see me when I'm sitting here?
Yes.
Yeah, okay. So I mean, if I hold up my hand, I wouldn't start at the fingertips like the first order streams, but maybe I'd start at the first major set of knuckles. And you know, if the network were going all the way down to my elbow, if I start doing things up here, again, that's going to help a lot. By the time you get to working down in the lower part, you'll have already made it more resilient.
Okay, one last question, anybody? Oh, here we go.
What are you most hopeful about in stream restoration and watershed health? After all that climate change discussion.
Good last question. I'm hopeful that because people care, a lot of people care about rivers, and they're willing to put their efforts and their money behind that care. And I'm hopeful. River restoration has changed a lot in the last 20 years. It used to be, you know, let's take a backhoe and let's create a perfect meandering form and then stabilize it in place. And we moved beyond that. There's a lot more diversity in what's being done, things like reintroducing wood, reintroducing beaver, mimicking beaver, connecting the channel and the floodplain. So we do learn and things do improve with time, and a lot of people care, and that will keep us on that trajectory, even if at the national level there's not the support for environmental protection or restoration that there has been in the past. Hopefully that will improve in future, but meanwhile local communities can do an awful lot, and most people care most immediately and most directly about the watershed that they live in and or that they go to regularly for recreation.
All right, Dr. Wohl, thank you very much. We so appreciate you joining us today. We look forward to hearing from you in the future, and I'm going to make sure that everybody in this room buys some of your books.
Thank you. Oh, and I will say you won't make me richer because all the royalties go to organizations like American Rivers. So yeah, definitely buy the books.
Thank you so much. Good night.
Thank you. Good night.